Module 2, Advanced Production, Transportation, and Safety. Lecture 1, Production System Design. A petroleum production system includes the well, surface facilities, and transportation infrastructure. Design considerations include flow rate optimization, balancing reservoir pressure and equipment capacity. Surface facilities, separators, heaters, and storage tanks to handle oil, gas, and water. Pipeline design, ensuring safe and efficient transportation to refineries or storage. Engineering decisions affect production efficiency, safety, and economic viability. Lecture 2, Drilling and Production Safety. Safety is critical in petroleum operations due to the high pressure and flammable nature of hydrocarbons. Key safety measures include blowout preventers, BOPs, prevent uncontrolled release of oil or gas. Emergency shutdown systems, stop operations during critical incidents. HSE practices, health, safety, and environment, training, monitoring, and compliance with regulations. Accidents in petroleum operations can have severe environmental and economic consequences, making safety a priority. Lecture 3, Well Testing and Performance Monitoring. Monitoring well performance ensures efficient production and reservoir management. Techniques include pressure volume temperature, PVT, analysis, determines fluid properties and reservoir conditions. Well logging, measures formation properties using electronic tools. Production logging, tracks fluid flow inside the wellbore. Decline curve analysis, predicts future production rates. Continuous monitoring allows engineers to adjust operations for optimal recovery. Lecture 4, Transportation of Petroleum. Once extracted, hydrocarbons must be transported safely. Methods include pipelines, common for oil and gas transport over long distances. Tankers and trucks, transport refined products or crude over shorter distances. Rail, used where pipelines are impractical. Pipeline design considers pressure, temperature, fluid properties, and environmental impact. Maintenance and monitoring are essential to prevent leaks and accidents. Lecture 5, Refining and Downstream Considerations. Petroleum refining converts crude oil into usable products like gasoline, diesel, jet fuel, and petrochemicals. Engineers must understand. Distillation separates hydrocarbons based on boiling points. Cracking breaks large molecules into smaller, more useful ones. Reforming and blending adjusts chemical properties for fuel specifications. Downstream considerations affect production decisions, especially regarding product quality and market demands. Lecture 6, Enhanced Oil Recovery and Reservoir Management. Enhanced Oil Recovery (EOR) techniques aim to maximize production from mature reservoirs. Thermal EOR, injecting steam to reduce oil viscosity. Chemical EOR, using surfactants or polymers to improve oil displacement. Gas injection, maintaining reservoir pressure with CO2 or natural gas. Reservoir management involves monitoring pressure, production rates, and water cut to optimize recovery over time. Lecture 7, Environmental and Regulatory Aspects. Petroleum engineering must comply with environmental regulations to minimize impact. Spill prevention and response, strategies to prevent and address oil spills. Waste management, safe disposal of drilling fluids, produced water, and chemicals. Emission control, reducing greenhouse gases and pollutants. Regulatory compliance, following local and international laws for environmental protection. Responsible engineering ensures sustainable development and corporate accountability. Lecture 8, Petroleum Economics and Project Management. Economic considerations influence petroleum engineering decisions. Key factors include project feasibility, evaluating reserves, production costs, and market prices. Investment analysis, assessing return on investment and risks. Cost management, controlling drilling, production, and transportation expenses. Time and resource planning, coordinating drilling, completion, and production schedules. Understanding economics ensures efficient resource allocation and profitable operations. Lecture 9: Future Trends in Petroleum Engineering. The petroleum industry is evolving with technological and environmental changes. Digital oil fields, real-time monitoring using sensors and automation. Advanced reservoir simulation, predicting reservoir behavior more accurately. Sustainable practices, reducing carbon footprint and environmental impact. Integration with renewable energy, hybrid solutions for energy production. Petroleum engineers must adapt to these trends to remain competitive and responsible. Module 2 Summary. In this module, we covered production system design, monitoring, and optimization. Safety, well testing, and environmental considerations. Transportation, refining, and enhanced recovery techniques. Petroleum economics, project management, and future industry trends. This module equips learners to manage petroleum operations efficiently, safely, and sustainably. This course on basic petroleum engineering has provided a comprehensive overview of petroleum industry structure, geology, and hydrocarbon properties. Exploration, drilling, well completion, and artificial lift. Reservoir engineering and production optimization. Transportation, refining, environmental and economic aspects. Safety, project management, and future trends. By mastering these principles, students gain the knowledge required to work in upstream and midstream petroleum operations and understand the fundamental concepts that govern the oil and gas industry.